7-3, test for parallelograms. Alright, so this goes along with yesterday's 7-2. We talked about parallelograms, and now we're going to be doing test for parallelograms, so these two lessons are closely related. So today we have 4 theorems we're going to talk about. So 1, 2, 3, 4 different theorems. Alright, so let's look at them. It says, the first one is if both pairs of opposite sides, so it has to be both pairs of opposite sides of quadrilateral are congruent, then it's a parallelogram. Okay. Theorem 2, if both pairs, both, okay, has to be both, okay, has to be both, not just one pair, but both pair of opposite angles of a quadrilateral are congruent, then it's a parallelogram. Okay. And then if the diagonals, plural, so both, okay, if the diagonals bisect each other, so they both of them have to be bisected, then the quadrilateral is a parallelogram. All right, so we talked about all of those things yesterday. And then here's one, okay? So if one pair, okay, just one pair of opposite sides is both, okay? So one pair has to be both. It has to be parallel and, okay, parallel and congruent. So it has to show that's parallel and congruent, then it's parallelogram. Okay, if it does not match both being for sure parallel, doesn't mean it just looks parallel. It has to be for sure parallel. All right, you have to have some sort of symbol, and it's usually, you know, a little triangle symbol here on both of them. It shows that they are parallel. All right, and congruent. Okay, so and congruent, you get your little tick marks. Okay, so it has to be both. Can't just look at it. It has to be for sure both. You have to be given visual confirmation on the shape itself for you to say, yep, that is definitely a parallelogram. Okay, so we're going to use these our theorems today, and first up we're going to identify parallelograms. Alright, so we're going to determine whether this shape here, whether this quadrilateral is a parallelogram, and we're going to justify our answer with one of our lovely theorems here today. Well, let me see. This pair of opposite sides is congruent, and this pair of opposite sides is congruent, so we can say yes, this is a parallelogram. And why? Well, both pairs of opposite sides are congruent, so therefore it's a parallelogram. Our first theorem today. Okay, so both pairs of opposite sides are congruent. All right, both pairs of opposite sides are congruent. All right, so we are a parallelogram. All right, so let's use these theorems to do some math, okay, and see when situations what the amount would be for our variable to guarantee it's a parallelogram. All right, so this is an eraser top, you know, one of those lovely pink erasers. So school supplies, the top of the eraser appears to be a parallelogram. So we're going to find the values of x so that the sides of the eraser are a parallelogram. Okay, so we're going to find what x and y has to be in order for this to definitely be a parallelogram. And if x and y are any other thing, can't be a parallelogram because both pairs of opposite angles have to be congruent. Okay, so there's only one set of x, y numbers where these can fully be a parallelogram. Okay, first up, it asks what theorem we're going to use. Well, I just referenced that second theorem, so it is that both pairs of opposite angles are congruent. All right, so that's the theorem we're going to use to prove this. Okay. So first up, we're going to find x. All right, opposite angles, set them equal to each other. 7x equals 56. Divide both sides by 7, and x equals 8. All right, next up, we're going to find y. Okay, opposite angles. All right, find y so that the opposite angles equal each other. They set that up for you. That was very lovely of them. And now we have to get all of our terms with y on one side and all of our terms without y on the other. And you know me, I always start with getting my variable on one side, and I always say my lowest valued variable loses, and my loser has to move. Now, can you start with another one of these terms and decide to move it? Yes, you can. As long as you math properly all the way through, your math will still math perfectly, and you'll still end up with the exact same answer I did. All right, so 4 equals the 1y minus 26. We're going to add 26 on both sides. And y equals 30. So when x equals 8 and y equals 30 is the absolute only scenario, these numbers both have to be true in order for this to be a parallelogram. So our answer is when x equals 8 and y equals 30, then this quadrilateral is a parallelogram. Or you can just draw the shape. Okay. So now if you were given this information and then you were told x equals 9. Well, if you're told x equals 9, then it would make this equation not true, and so even if this was true, the whole thing would not be a parallelogram. Or if in this scenario you were told y equals 45 and you solve this and this still equals 8, well, then both of them would not be equal, and so then therefore we would not have a parallelogram. All right, so this is the only scenario when x equals 8 and y equals 30 that this indeed is a parallelogram. All right, so new section today, so new question and answer in your summary. How can you use the properties of parallelograms to construct parallelograms? All right, so you answer that down here. All right, let's go on the back. Just 2 more examples. All right, so we are going to identify parallelograms on the coordinate grid. You can do this a couple different ways. This one, we are going to actually use our diagonals, and so we are going to use our midpoint theorem. And so that means they must bisect each other, okay? So the diagonals must bisect each other. Okay, so both of your diagonals, okay, they must bisect each other. Now, how does the midpoint theorem fall into this? Well, in order to tell that your diagonals have bisected each other, your midpoint would be the exact same for both. Okay, your midpoint point on the grid, the coordinates, would be the exact same. So this is the theorem we're using. We're using theorem number 3. And so the diagonals bisect each other. All right. Then the quadrilateral is a parallelogram. Okay, so they would have to bisect each other, which means the midpoints would be at the exact same location on this grid. So in order to find the midpoint, we need the coordinates of GJ. Okay, so this is one diagonal. Okay, so G and j. Let's find those coordinates. G is 4, 2, and j is -2, -1. So our midpoint formula is here. So this is x1, y1, x2, y2. So you add your x's together. So 4 plus a -2 divided by 2. And then you add your y's, 2 plus a -1 divided by 2. All right. So what is the midpoint of this diagonal? Well, 4 plus a -2, well, that's the same as 4 minus 2. That's 2. Divided by 2 is 1. 4 plus a -1, that's the same as 2. 2 plus a -1 is the same as 2 minus 1, which is 1 over 2. Okay. So at 1 and then 1/2. That'd be the midpoint of this line. All right, let's do our other diagonal. Oh, that was a really bad diagonal. Wow. All right, let me get my ruler out for this one. All right, there we go. That's a better diagonal. So let's check out this diagonal. Okay, so we need the coordinates of F and H. So F and H. All right, F is -2, 4, and H is 4, -2, x1, y1, x2, y2. So let's fill in. Let's see, x1, -2 plus 4 divided by 2. And then y1 is 4 plus a -2 divided by 2. Let's see what our midpoint is for this diagonal. So -2 plus 4 is 2. 2 divided by 2 is 1. 4 plus a -2, or 4 minus 2 is 2. Divided by 2 is 1. Your midpoints are not in the exact same location. And since your midpoints are not at the exact same coordinate, we did not bisect both diagonals. So the midpoint GJ does not equal, okay, does not equal the midpoint of diagonal FH. So this is not a parallelogram. Okay? They are not a parallelogram. And sometimes that happens. Sometimes you prove that you are not a parallelogram. Perfectly okay. All right, now let's work on this coordinate proof. Based on when we tested on this skill the first time, need a little help with this. All right, so what is this? We are going to write a coordinate proof for the following statement. And when it wants a coordinate proof, it means it wants you to put that shape on the coordinate plane, but it's not giving you any coordinates. It's wanting you to use letters for the coordinates and 0, okay? Here's what it wants us to prove. If one pair of opposite sides of a quadrilateral are both parallel and congruent, then the quadrilateral is a parallelogram. All right, so one pair has to be both parallel and congruent. This is theorem 4 from today. Okay, so it tells you exactly how to position a quadrilateral on a coordinate plane. Okay, shows you exactly what you would do to get this on here and what your coordinates would be for this parallelogram on a coordinate plane. Okay, stepped it out for you, did it for you. Step 2, we're going to use the figure to write a proof. Okay, so given, here's what we're given. We are given that quadrilateral ABCD, four-sided shape. So we are given that side AB is parallel to side DC. Okay, so we are given that they are parallel. Okay. So we're given that. These are parallel. And that AB is congruent to DC. So we are going to prove that when one pair of opposite sides is parallel and congruent, that this indeed is a parallelogram. And the way we're going to do that is we are going to use the slope of these lines here, because the slope of these lines here would be the same. Okay, so if these lines have the same slope, then these lines have to be parallel. Okay, because if these lines have the exact same slope, then these lines are also parallel. Okay, so let's do that. Now, if you don't remember your slope formula, okay, your slope formula, because what we're trying to do is we're taking this theorem, and if we can prove that these two lines are parallel, we already know these two lines are parallel, and if both pairs of parallel lines are parallel, then your quadrilateral is a parallelogram. Okay, so we are using that if, yeah, both parallel. So if they are both parallel and congruent. Okay, so if this pair is parallel and this pair is parallel and these are congruent, that makes these have to be congruent, and so therefore this will be a parallelogram. Basically, we're proving kind of all of these theorems all in one. So here's our proof. Sentence format, and then we're going to do some math. Okay, so by definition, a quadrilateral is a parallelogram if opposite sides are parallel. Opposite sides are parallel. We are given that these sides are parallel, so we need to show that these sides are parallel. In order to show these sides are parallel, we need our slope formula, which is M is slope. It is the change of y. Change of y, sorry, over the change of x. All right, so we're going to use our slope formula, and I already filled it in for us. So AD, this is your x1, y1, x2, y2. Okay, filled it in for us. So C minus 0 is C, and B minus 0 is B. Okay. And then the slope of BC. Okay, so x1, y1, x2, y2. Again, filled it in for us. C minus 0 is C, and B plus A minus A, well, those kind of cancel each other out, and you're left with B. So CB does in fact equal CB, and since they have the exact same slope, these sides are also parallel. Okay, and we just proved that. So we're going to pull in some of our formulas that we have learned up to this point to do in these skills. Your assignment is in McGraw-Hill. Make sure you have a piece of paper, show your work. Good luck.